Welcome to the Purr Podcast, your favorite feline-focused podcast, where we dive into all things feline, medicine, surgery, behavior, and of course, a sprinkle of veterinary gossip along the way.
I'm Dr. Jolle Kuppenstein, feline fanatic, surgery nerd, and self-proclaimed lover of all things awkwardly cat-related.
And I'm Dr. Susan Little, proud cat vet, podcast enthusiast, and your guide to the wonderfully weird world of feline medicine. Let's get started.
Hello, this is Dr. Jolle Kuppenstein.
Oh, that's your FM radio voice.
I know it is. It is.
And this is Dr. Susan Little.
And this is the Purr Podcast.
Yes.
And this is the second episode.
Yes.
We're talking about viruses.
Yes, with Dr. Terza Brostoff.
And we talked about FIP. I just have, the first question for you is, what viruses excite you tremendously?
Good question.
No, this is definitely one of them. It's one of my favorites.
I often say that too. It's because it doesn't play by rules.
It is
That's why it's fascinating.
complicated. It's such a complicated beast.
Yeah.
It really is. It's got a remarkable pathogenesis. It's crazy. Yeah, it's weird. It's a weird one.
It doesn't transmit the way you
Yeah.
think viruses should.
I've definitely played with a lot of viruses. You know, we kind of, our lab kind of breaks it down into, do you like the DNA viruses or the RNA viruses? It's 100% about the RNA viruses.
Yeah, I hear you. So in the previous episode, I started to say that something you said reminded me of something that Dr. Jules Beatty said. And then Beatty, see, there you go. I've lost it. I'm just going to say Jules B now. Sorry, Jules. I've just lost it.
We apologize.
No.
We apologize.
Yola,
I
formerly.
apologize for Dr. Susan too, but it's Jules Beatty.
How do you remember? Yeah, because you're just better than me. See, I've lost it again. Hold on 1 second. It's. Why does he put up with me? It was because you mentioned when you when we're back at UC Davis at the start of the pandemic that any research on coronaviruses, right, was somewhat exempt, right? Mm-hmm. Yeah, and so we were talking with in our episodes with Jules about that too, about coronaviruses, and just I think Yola had said like, you know, veterinarians know a lot about coronaviruses. I mean, the species we deal with have their coronaviruses, right? Yeah. And so, especially early in the pandemic, it used to just frustrate me seeing the news come up. Talk to a veterinarian, like who does virology or, you know, microbiology, because man, like they can tell you a lot.
Mm-hmm.
So my question to you is then, do they talk more to you?
Oh yeah, how integrated is like human virology and let's say. Yeah.
So we have a small group of coronavirus researchers at Davis, and I am only familiar with one that works on non-specifically veterinary coronaviruses, Dr. Simon Anthony, and he mostly works on bats, looking at them and bat coronavirus evolution, its potential for spillover, things like that. So I'm also full disclosure, I am not a coronavirus expert by any stretch of the imagination. But you know, I've been working with it for a while now, and we haven't had much overlap, honestly.
Okay.
Yeah.
Which is surprising because I think they would have learned over
I take that back. Sorry. Dr. Lark Coffey at Davis as well. She also works on SARS-CoV-2.
Right.
There you go.
Yeah.
It would seem to be a bit of a natural field for some collaboration anyway, right?
Yeah. There a lot of their work has been demonstrated and validating rodent models for use. So,
right.
Yeah, I remember that the team in Utrecht, when I was there a long, long time ago, was already working with FIP and coronavirus for a long, long time. And so, as a student, I was quite interested in it. But then when the whole coronavirus, I was like, you know, I know all these things that people say, and I know that they're wrong.
Yeah.
Because that's and then I'm so surprised that from the human side, because there's so many articles also in published literature about coronaviruses in small animals. that they didn't go back and say, hey, maybe we should reach out to these people and get some information.
Well,
experience.
and thank goodness SARS-CoV-2 is behaving nothing like feline coronavirus.
Oh, gosh.
I mean, we really,
it could have been so much worse.
It could have been so much worse. We really lucked out in terms of how relatively,
We're not done yet.
I know.
Well, no,
but how
it's
straightforward
still,
vaccine development was, even from that standpoint.
yeah, the timing was good, I think.
Oh, it was
for vaccine development.
It was exceptional,
Right.
but we got lucky that a lot
True.
of these phenomena that we see, and a lot of the reason we don't have good vaccines for cats are not true for SARS-CoV-2, because that would have been a nightmare.
Yeah.
You know, we're 60 years into this virus in cats, and we still don't have on the market a really good vaccine.
Yeah, so I do want to talk about vaccines a bit, but before we go down that rabbit hole, so the vaccine bit aside, there are probably some similarities between the disease in COVID in people and FIP in cats, right? So I'm thinking of the role of inflammation. Why do some people get long COVID? Are there similarities between that and maybe some of our FIP cases? So, so what do you know? What do you think about that? It begs the question to me, doesn't it?
It's really interesting to think about. I think the amount of granulomatous disease we see with FIP seems to be fairly unique to that particular disease.
Yeah.
And I don't think, we're just now starting to really unravel some of the mechanisms that we're suspecting are at play for long COVID. But even our ability to diagnose long COVID is really, really, we're just now starting to get some objective diagnostic
criteria.
For long COVID. I don't know that they're necessarily those two specific viruses, but I think the more people have looked at long COVID, the more they're realizing that there are a lot of viral infections that do not end when we clear the acute phase of the virus. And this has been recognized for influenza. This has been recognized for respiratory syncytial virus. A lot of other viruses we're now recognizing cause long viral infection syndrome, and the literature on that is starting to increase too. So, what do all viruses have in common? Probably to some extent the way that your immune system is responding to it. And of course, inflammation is going to be a big part of that too.
Yeah.
So I think from that standpoint, yes, but I really do think feline coronavirus is kind of a unique beast.
Yeah. Well, cats are unique, so therefore
they don't like to.
Yeah, and I often say that cats really like inflammation. They seem anything. I'm going to get inflamed. Like it doesn't matter what it is.
And I'm going to stay inflamed for a really long time.
I know. I don't like the cat food. I'm going into inflammation. Like seriously, they're masters at inflammation, right? Yeah. So in a way, I guess it doesn't surprise me that they'd be subject to over exuberant immune responses. So great news on the treating FIP front. Finally. But let's circle back to vaccination. So that's been a problem.
Sure has.
Yeah. So for our listeners, if you know, can you recount a little bit about veterinary medicine's history with FIP vaccines? Because we have a little bit of history.
Yeah,
right.
We certainly do.
Yeah.
And I would be. It would be bad to not go just a little bit into the pathogenesis of the virus because it's important to understand why we've had such a hard time with these vaccines. So feline coronavirus comes into what have historically been called serotypes. It's probably not the best word for them.
Melissa Kennedy, who was a clinical pathologist at University of Tennessee, lovely, lovely woman, used to call it the good twin and the evil twin.
Okay.
And I thought, that's pretty good.
Yeah.
Sorry. Anyway.
I don't disagree. I would say that about the biotypes.
That's what I meant. You're talking about serotypes.
Yeah. So serotype 1, so feline coronavirus 1 is the kind of OG. This is the cat virus. This is the one that likely first arose in cats. We also have feline coronavirus type 2, which is the result of a crossover event just in that outer spike. So a genetic recombination with a dog coronavirus.
Will you tell her?
Oh, I'm so sorry. I said I know.
Yes.
The D coronavirus.
You could have said
canine.
We'll forgive her, but only
Okay,
for
we'll forgive you that one.
I apologize. It'll never happen again.
See, it's the canines causing trouble.
Yeah.
No,
Always.
it's
It's the cat viruses.
It's always the same thing.
Well,
Wait until the cows get it.
oh, they have their own. So this type 2 feline coronavirus, the only difference is that big outer spike protein, which is the one I think everyone's familiar with because it's what the human vaccine for COVID-19 is against, that is coming out of the canine version of this virus. The rest is entirely the same. For better or worse, that spike, we actually know what the receptor on the cell is for that virus, for type 2. And so we can grow it in a dish, and it's been the one that's been best studied. If we're coming up with a live attenuated vaccine, it's going to be a type 2 vaccine because it's the only one we can easily grow.
Really can't easily work with serotype 1.
What exactly? Right. The problem is type 1 is the one that's important in the world. So it's the one that's more biologically relevant. It represents probably over 80% of actual circulating virus in the world. We don't know the receptor. We can grow it in a dish if we do some manipulations to it, but then we're starting to add a lot of artificialness to this virus.
Right.
And it's just been really, really challenging to work with in the lab, which is what we need to do to be able to make a vaccine.
So we still don't know the receptor.
No. Type 1. Yeah. And there has been a lot of work that has been done trying to tease it out.
Wow.
It's likely a combination of receptor and some number of co-receptors as well. And we haven't figured out the mix yet.
Exactly?
Yeah. So point of the story, most of our work has been on type 2, and the original vaccine that became USDA approved, and this was quite a long time ago, is in fact an attenuated type 2 virus. There are a couple of issues with this vaccine. One is since its inception, there have been safety concerns because it's a type 2. Its actual ability to prevent FIP, prevent coronavirus infection, is also questionable because if these cats are recognizing the type 2 spike, that might not be enough for them to actually, prevent infection or clear an established infection. And then the other really big problem is most kittens are infected with coronavirus when they're incredibly young.
Yeah.
Reports as early as, I think, 2 to 3 weeks. And most cats, over half of cats that wind up with coronavirus infections are seropositive by 8 weeks, which is when we typically start vaccinating. In addition, the USDA label for this approved coronavirus vaccine, this FIP vaccine, is starting vaccination at 16 weeks of age. That ship has sailed because the goal of this virus is actually to vaccinate a naive cat who hasn't been infected yet and prevent them from getting their first infection.
So 16 weeks.
So these are the reasons. No, these are the reasons AFP does not recommend using this vaccine.
What if you give it to queens that are
I don't know that that's been tried. Perhaps at this point it has. But remember, the majority, and the majority of our cats that are getting adopted today are not coming from breeders. The majority are still coming from shelters or the outside.
And probably a lot of those, a certain percentage of those queens may have antibodies anyway. They may, right? And so
it's unlikely that those, I shouldn't say that. We typically see the highest rates of coronavirus infection in high density environments, which includes breeders, but it also includes shelters.
Exactly.
That wouldn't work.
I'm just thinking, it might not work for the queens itself.
So it's a mucosal vaccine.
Yeah.
So I don't even know that there's necessarily going to be a lot of antibody transfer from queen to kitten. The goal is to get high mucosal IgA and prevent infection. So, so that's problem number 1. Problem number 2 is, and this is one of the reasons that safety concerns have arisen for this original vaccine, is that there's this really crazy thing that happens with coronavirus or with feline coronavirus, where low-ish levels of antibody can actually make disease worse. And so that is the other reason that I think it's been really, really difficult to generate a safe vaccine. Now, that only happens for vaccines that are causing an antibody response to one of the surface proteins of the virus. Because what effectively happens is we know that as coronavirus. There, initial infection is of the GI tract. Mm-hmm. It's in the epithelium of the GI tract. Mm-hmm. And then the internal mutation theory, which is mostly accepted, says that the virus inside the cat develops one of a number of mutations, all of which allow the virus to leave the intestines and enter monocytes and macrophages. And away it goes. And that's how it spreads throughout the body. So if you have low levels of antibody binding at the surface of the virus, one of the normal things that happens when you have something bound to antibodies is that macrophages and monocytes take it up from the other end, from the handle of the slingshot of the antibody. And so most viruses can't replicate in that cell type. So the virus gets inactivated and it's done. But in this case, it actually increases how quickly the coronavirus can spread throughout the body. And it can make disease much, much worse and much, much faster. And so most of our strategies.
That's crazy. That little virus thought of that. It's amazing.
So clever.
Right.
So clever. So this is a big problem, though, because almost all across the board, almost all of our vaccine strategies, because this is the logical thing to do, elicit an immune response to one of these outside proteins, because that's what you have to do to prevent the virus from getting into cells. They're typically really highly immunogenic. They're great antigens, and that carries safety concerns for feline coronavirus. And that's been one of these big issues.
Any other virus that can do the same thing?
Yeah, there is one other, there's one that's the poster child of this. So this, I don't think I named it. This is called antibody-dependent enhancement. The poster child in the human world is dengue virus, although there's actually a lot of debate now in the literature as to whether or not that is the reason that people with dengue get severe disease, because they've been documenting more and more that on initial infection with dengue virus, some of these people are getting the equivalent of that very severe disease, the horrible vasculitis, the breakbone fever, all that on first infection.
Right.
So law would have it that ADE, you have to already have antibodies on board.
Yeah, it can't be first.
It can't be your first
time you see it.
So that's the other poster child in human medicine. The other one that we know about in veterinary medicine is a disease we don't think about very often. It's Aleutian mink disease. So Aleutian mink disease virus is another one where antibody-dependent enhancement plays a role. So.
Yeah, it's still not a common phenomenon.
No. It's and thank goodness.
I
mean, if that had been, if that had been a concern with SARS-CoV-2.
So, given where we are now and what manufacturers have learned from making COVID vaccines, can we circle back now to FIP?
Yeah. So
can we have a new look at this?
So there's actually been, and I shouldn't say that there's been no progress. There have been a handful of groups that have been working on using different strategies to try and vaccinate for feline coronavirus, whether or not they're trying to prevent infection or trying to prevent that jump from enteric to the FIP form of the virus.
Good to evil.
But again, so what we've decided to do with this, and I think there's been a light theme in the literature for a while now of looking for other targets within feline coronavirus that aren't on the surface.
Okay.
And that's what our group is doing as well.
But if it's not on the surface,
how the heck is it going to prevent disease?
Yeah.
That's a great question. So we're targeting one of the only structural protein that's only present on the inside of the virus, which is called nucleocapsid, or N. Mm-hmm. And the theory is, remember, we have two big arms of the immune system. There's the humoral response with antibodies and B cells, and then there's the cellular response with cytotoxic T cells.
Right.
So our goal, we know, there is no way to get only one of these arms activated when you vaccinate.
You cannot separate them.
Correct. And that's fine. We just need to not have the antibodies that are produced by our vaccine or in response to our vaccine attached to the surface of the virus.
Okay.
So we are banking on having the cats develop a really robust cell-mediated immune response. Okay. And the way that's going to work is that the T cells basically survey cells throughout the body, asking what proteins those cells are producing on the inside. And the way our immune system works is if it's something that's supposed to be in the body, it says yourself, I don't care about you, I'm going to move on.
Yeah.
But after we've mounted an immune response to something we know isn't self, like feline coronavirus nucleocapsid, that T cell is going to come by. The infected cell is going to say, hey, I'm making this. The T cell is going to say, oh, that's that. We know that that's not self, that's virus. I need to kill this cell. And so the already infected cells are going to get killed. So my goal is not to prevent a cat from getting coronavirus. That ship's going to sail long before we can vaccinate them. My goal is that we're going to train the cat's body to recognize cells that have been infected and wipe those out before the virus has a chance to leave the GI tract. That's the goal.
How often do you train the cell?
That's a great question. How many doses of vaccine do we need to use? And I don't know the answer to that because remember, these cats are also seeing natural infection, which is going to be a boost. But if we can specifically get the cat to make a stronger cytotoxic response to nucleocapsid, there's a much higher likelihood that cat's going to recognize infected cells and wipe them clean.
So to some degree, the cat's immune response would it not be somewhat independent of what your vaccine target is? I guess what I'm getting at is that there's variability on the cat side.
Absolutely.
Right.
Our hope is that if we give them a whopping dose of N, they're going to be really excited about N.
Right. So you're going to ultra sensitize, for lack of a better word, the immune system to look. Right.
But exactly.
Would we worry that we could also get an exuberant antibody response from that?
We shouldn't have to because antibodies to N are not going to be working to prevent the virus from getting into a cell.
Right.
They will certainly be made, and there are a lot of other FC-mediated functions that can actually enhance an immune response in general. But that's not our goal for how we're going to protect these cats from FIP. Our goal is that the CD8 T cells can recognize already infected cells and wipe them out shortly after infection.
Yeah. So we're by avoiding surface targets.
Exactly.
Yeah, we're avoiding that.
Yeah.
Has that not been tried before?
So there have been a handful of vaccines using N as a target. There was an older one. I don't remember the year or the group, but they were using a baculovirus expressed nucleocapsid protein, so an antigen. It was one study published once a while ago. It was promising-ish. The problem is when you provide protein just by itself outside of the cells to an animal, they are going to bias their immune response to something extracellular.
Right.
And so this is one of the advantages of the mRNA vaccine is we are having the animal produce this protein inside the cell. So it's going to be presented in a way that those T cells that can kill cells
are naturally looking for it.
Exactly.
Right? Yeah. Gotcha.
It's not impossible, but it's much more difficult if all of the protein is coming from outside of the cell to get a really robust cytotoxic T cell response, which is what you need for this type, right? Yep. We've already agreed antibodies are going to help. They're not necessarily going to hurt, which is important too, but they're not doing the heavy lifting. There was another one recently as well. So in other species, including humans, adenovirus vector vaccines are really good at eliciting CD8 responses. There hasn't been a lot of work done in cats looking for them. There have been a couple. I think there was a rabies vaccine that was tried or something. But, that hasn't really taken off in the cat world. But
it's a common model, I think, in human vaccine production.
Absolutely.
Yeah.
So that's been tried. I think that was relatively recently published. So certainly another, I am 0% against us having 5 vaccine options for FIP.
Oh, gosh, yeah.
So my question is that if a lot of your GI cells are infected and you use this technique and now the body says, whoa, look at all those cells, let's start killing them. What are the side effects?
We could certainly see some side effects from that. Remember, GI turnover is real fast.
Right.
So hopefully,
but except when it's in the cells that create, if you hit the stem cells in the GI tract, you might kill those too.
Yeah, I think it's. I'm not going to say that. I think it's surface epithelium that typically gets infected.
Yeah, I think you're right. I think it's surface epithelium, and I would guess that the turnover is naturally very high, right? So you shouldn't get into a situation where you're just wiping them all out. I would think that would be.
I would also assume that if you had enough feline coronavirus affecting a massive proportion of your GI tract, that cat probably is going to be one of the ones that has diarrhea. So hopefully we don't vaccinate a cat with active diarrhea and we wait for them to be a little bit healthier before we ask their immune system to do yet another thing.
So it's an interesting approach because we're not looking to prevent infection. We're looking to prevent disease.
Mm-hmm.
Right.
Exactly.
Right.
That is 100% the goal of this vaccine.
Yeah.
Well, and the advantage of that is, again, we're never going to catch these cats before their initial infection.
Yeah.
And so this strategy really, the way that cats have to be infected to have the ability to develop FIP is still also a little bit gray in the literature, whether a cat is chronically or persistently infected or whether they're just giving infections back and forth to each other. One way or another, the virus is in the cat for longer than just one acute, in and out.
Right.
But the hope is that, if they have an established chronic infection, that we're able to clear that. And if it's a matter of getting it over and over and over again, that once we have a good memory response with these T cells that can kill infected cells, the cat gets a new infection, the cat clears the infection.
Yeah. I think didn't Janet Foley do some work showing that some cats are more likely to be persistently infected. Some go through this, what did she call it, like susceptible immune thing?
It's a really hard question to tackle. Because even cats that could hypothetically be chronically infected aren't necessarily going to be shedding the entire time too. Yeah. So it's a really difficult question to answer. Yeah, unless Yola wants to biopsy a bunch of cat GI tracts.
Always. I'm always ready.
I do want to point out, though, that we have other feline vaccines that work at least partly on the preventing disease versus preventing infection model.
That is
so
true.
It's not
a lot
novel.
Of vaccines for all
species. It's not a novel idea. Mm-hmm. I mean, we tend to think about it preventing, but it's preventing disease.
It's an almost impossible bar to set because it's a natural thing for the cat's immune system to contract after some period of time, right? Yeah. If we had antibody levels that were sky high
for
and neutralizing,
our
blood would be mud.
Yeah.
Oh, well, once again, we're at time. I know. It's really bad. I'm sorry to be the bearer of bad news here, but this has been great.
It's such a fascinating time, isn't it?
It is so cool.
Like coronaviruses, not that I cheered on COVID, but, part of me is going, coronaviruses, finally, they're getting some street cred here.
Right.
Yeah. And with, the work that you and your colleagues are doing and others around the world, I think there's been a renewed interest and excitement.
Yeah.
I also think it's, like I said before, it's not the end of the story. I mean, we're just at the beginning. That's this whole coronavirus thing. Everybody's like, oh, it's over now.
Very cool.
Small.
I'm sure Niels Peterson is smiling. So. Right? Yeah, absolutely.
Oh, well, thank you so much for being on with us.
It was an absolute pleasure.
Yeah, you'll definitely, we'll invite you back. We don't invite everybody back. Just saying.
It would be a privilege.
We would love to invite you back, though, because it is such a fascinating topic. So thank you.
It is, and things are changing, so that's nice.
This is the Purr Podcast, where we talk cats, laugh a lot, and learn something new every episode. Together, we bring you the latest updates, surprising cases, expert interviews, and just a touch of chaos, because nothing with cats ever goes as planned.
So whether you're a seasoned veterinary pro, a new grad, or you're just here for the cat puns, you've come to the right place.